So today we're going to look at some angle relationships that are some of the things that we just have been taking for granted about triangles, but also just to emphasize some of the relationships in triangles between the angles. So one fact about triangles that we've taken for granted in our study of geometry is that if I add up all the angles of a triangle, that I'm going to get 180 degrees. So let's prove it today. So I have a yellow triangle down below here, and we're gonna number the angles so that we can be clear about what we're talking about. So let's number the angles. We'll call this angle 1, angle 2, and angle 3. And I'm going to need some parallel lines, which I don't have right now. So let's go ahead and add some lines that are parallel. Now, when we add something to this, sometimes we call it auxiliary. So this word auxiliary is something that's added or extra. And so these lines are going to be auxiliary lines. And I'm gonna add two. One of them is just going to be the side of the triangle, but I think it helps to extend it a little bit. So I'm going to take my drawing tool here and see if we can draw two lines. So this will be one, which is not quite what we wanted. So I want it to be a straight line. So let's see if we can do a better job than that. And there we go. And I want to move this. It's right like that. The other line that I'm going to draw is just going to be an extension of the side of the triangle. So I'm going to take the drawing tool and see if we can just extend that side of the triangle. This time I want to move that line to be right there. Yeah, sorry for that. It took me a little while to figure it out. All right, so we're going to number the other angles here, and so we numbered the interior ones red. So let's use black for the outside. And so I need to number this angle is 4 and this one is 5. And we have two parallel lines here. Because they're parallel, we know from our previous work that this transversal, which is the side of the triangle here, so this transversal right here is going to make angle 3 and angle 5 are going to be alternate interior angles. And we know that when a transversal crosses parallel lines, that alternate interior angles are congruent. So I know that angle 5 is going to be congruent to angle 3. And using similar reasoning, I also know that this transversal from this side of the triangle makes angle 1 and angle 4 alternate interior angles. And so we know that angle 4 is congruent to angle 1. And given that information, we know that this is a straight angle if I add angle 4 and angle 2 and angle 5 together. So I know that if we add the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5, I'm going to get 180 degrees. But because angle 5 and angle 3 are congruent, we know that the measure of angle 5 equals the measure of angle 3. And because angle 4 and angle 1 are congruent, we know the measure of angle 4 is also equal to the measure of angle 1. And so we can substitute in those values. So instead of using angle 4, right, we can say, okay, I'm going to use the measure of angle 1. And instead of using the measure of angle 5, I can say I'm going to substitute in the measure of angle 3 because they are equal to each other. So that's the substitution property of equality. And so now I have exactly what I want. I can take the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3, which are those three angles of the triangle, angle 1, angle 2, and angle 3, and they are equal to 180. So that equals 180. And so therefore we've proved the theorem that the triangle's sum of the angles is going to be 180 degrees. Okay, so there are two theorems that we call corollaries to that angle sum theorem. And a corollary is just a theorem that follows directly from another theorem. It means that if the first theorem is true, then this theorem is going to be also true. And so because we know that if I add the angles of a triangle together, all three angles, I'm going to get 180. These two things directly follow. And there's two of them. One of them says that if I add the other two angles of a right triangle, the two angles that are not 90 degrees, that those have to equal 90 degrees when I add them. The other one says that if I have an equiangular triangle where all the angles are the same, that if each of those angles has to be 60 degrees. So as part of your assignment today, you have to pick either the first one about the right triangle or the second one about the equiangular triangle and explain to me why they are true using Flipgrid. So that will be part of your assignment for today. So how do we use those theorems? Well, let's pretend we have a right triangle here. And in this right triangle, it's one of the angles is, of course, 90 degrees because it's a right triangle. And one of the angles is going to be 22.9 degrees. So this is triangle with angles M and N. So it says angle M is 22.9, so this will be M. Angle N is the other acute angle that's not the right angle, so this would be N. And if I know that angle M is 22.9, how would I find angle N? Well, our theorem tells us that if I add 22.9 plus the measure of angle N, it's got to equal 90 degrees. So I can just do that subtraction. And so 90 minus 22.9. And so what do we got? 90 minus 20, that would be 70, right? And if I take 70 minus 2, that's 68. And I have to take away 0.9, so that's going to be 67.1. And so 67.1 degrees would be the measure of angle N. Of course, you could just use a calculator. But, so that is how you'd use that theorem. So some quick vocabulary here. When we talk about the angles in a triangle, there's interior angles, such as in this picture, angles 1, 2, and 3. And then there's also exterior angles. Only one of the exterior angles has been drawn here. It's angle 4. Angle 4 is the exterior angle at angle 3. We also talk about the relative positions of the angles. And so the word that we're going to talk about is when we use the word remote. Okay? Remote is describing the relative positions of two objects, and it means, essentially it means far. And so when I talk about this, this picture here that we're looking at, angle 1 and angle 2 are remote interior angles relative to angle 4. Angle 4 is remote exterior relative to angles 1 and angle 2. So So one pretty cool relationship in triangles is between those two remote interior angles. In this picture, angles 1 and 2, and the remote exterior angle, angle 4. Turns out that if you add the remote interior angles, angle 1 and angle 2, you're going to get the same value as the measure at angle 4. And so a lot of these problems are kind of like little angle puzzle problems. And below, you can see that I've drawn a triangle, a yellow triangle. Here it is. And I've extended one of the sides so that it is a line, lies on that blue line. And we're going to number the angles of this triangle. So we're going to call this angle 1, angle 2, and angle 3. And of course, this is our angle 4. We're going to use that same trick that we used when we were doing the angle sums to draw an auxiliary line. Remember, auxiliary means extra. And so I'm going to take my drawing tool here and see if we can make a line that goes through vertex 2. Here it is. Just adjust it a little bit. Let's see if we can. There we go. Move it. All right. So right now our picture has these two blue lines that are parallel to each other. That's important because that creates these alternate interior angles. So I know that angle 4 is going to be the same measure as the sum of this angle right here. Let's give this a number, angle 5. So angle 4 is going to have the same measure as angle 5 plus angle 2, because those would be alternate interior angles between the parallel lines. So I know angle 4, the measure of angle 4 equals the measure of angle 2 plus the measure of angle 5. But I also know that by alternate interior angles, that this angle 5 is going to be the exact same measure as angle 1, because those are also alternate interior angles. So we know that the measure of angle 1 equals the measure of angle 5, because those are congruent angles. So we can substitute in the measure of angle 1 anywhere that we have the measure of angle 5. So I can say the measure of angle 4 is going to be equal to the measure of angle 2 plus the measure of angle 1. And there we proved that. So we proved the theorem up above that the remote exterior angle, angle 4, is always going to be equal to the sum of the two remote interior angles. All right, so how would we use that information to solve this problem? And the problem is that I have this triangle GHJ, and I want to find the measure of angle J and the measure of angle H. Well, we can see that they have algebraic expressions for the two remote interior angles at J and H. But I know by that remote exterior angle theorem that if I take the measure of angle FGH, the remote exterior angle, and the two remote interior angles, that the sum of H and J are going to be equal to 126. And so we can write that out. So I know that if I take the measure of angle H plus the measure of angle J, it's going to be equal to 126. And we do know we know the algebraic expressions for angle H and angle J. So we have 6x minus 1 plus 5x plus 17. That's going to be 126. So we just have to solve this for x, and then once we have x, we can substitute it in to find h and j. So 6x and 5x, that would make 11x. And I have 17 minus 1, so that's 16 is 126. And I'm running out of room here, so I'm going to move over to the side. So I'm going to have, I'm going to subtract 16 for both sides. So we have 11x is going to subtract 16 from 126. So that's going to be 110. And so I know that x has to be, by dividing by 11, is going to be 10. So x is 10. And once I find x, I know the measure of angle J is going to be, if I multiply 5 by 10, so that's 50, plus 17, that's going to be 67 degrees. And for angle H, if I multiply 6 by 10 and subtract 1, so that's 60 minus 1, that would be 59 degrees. And so therefore we use that remote exterior angle puzzle theorem to solve this problem. All right. The last theorem we're going to talk about is called the third angle theorem. And it simply says that if I have two triangles and I know that two of the angles in the first triangle have the same measures as two angles in the second triangle, well, that third pair of angles has to be congruent to each other. So how will we show that? Well, we know for sure that the angles of the first triangle, if I add them together, equals 180. So measure of angle L plus the measure of angle M plus the measure of angle N, that is 180. So that's going to be equal to, if I add the other angles in the other triangle together, that's also 180. So those are equivalent. So the measure of angle R plus the measure of angle S plus the measure of angle T. And this does not look like a plus sign. Let's fix that. All right. So what do we know? Well, I know by this picture that angle L and angle R are congruent. So angle L and angle R have the same measures. So these are, whatever number that measure is, it's the same. So I'm going to be able to subtract that from both sides using the subtraction property of equality. That is also true for angle M and angle S. I can subtract those because they are also congruent to each other. They have the same measure. And when I'm done, what I'm going to be left with is the third angle. And there it is, angle N and angle T. So let's write that out. The measure of angle N is going to be equal to the measure of angle T. And that means that angle N, by the definition of congruent, is going to be congruent to angle T. And that's what we wanted to show. So those, if two angles of one triangle are the same as two angles in another triangle, well, that third angle is also congruent. That third angle pair are congruent to each other. Okay, so how do we solve a problem like this using the third angle theorem? Well, we can, if we look at the picture, we can see we have two right triangles, and we have a right angle at B, a right angle at E, so they are the same measures. And we also have angle A marked as congruent to angle D. So we have two angles and two triangles that are congruent to each other. And so what that tells us is we know right away that the other angles, angle C and angle F, are also the same. And so we can just set up an equality. We can say y squared equals 3y squared minus 72. And if we solve this using our algebra, we subtract y squared from each side. So if I move the y squared to the right side, and I take the minus 72, add that to both sides, so it's going to the other side, we're going to have 2y squared is going to be equal to 72. I'm out of room at the bottom, so we're going to move up. So if I have 2y squared equals 72, and we divide by 2, y squared equals 36. So we know that the inverse operation of squaring something is the square root. We also know that the answer to this algebra equation has two answers. The answers would be positive 6 and negative 6. But because we're talking about lengths, we know we can discard the negative answer. So y is going to be equal to the square root of 36. Y is going to be equal to positive 6. And so now we know what y is, and we actually, if we just wanted the angle, because the angle is equal to y squared, the angle is going to be 36. So we wouldn't need to take the square root to find the angle. But if they ask us to find y, we have to take the square root. So angle C and angle F are equal to 36 degrees.